Hello and welcome again to my channel. In this video I'm going to talk about a subject related to pumps, information that everybody should know. It has some information about pump curves and some information about compressors, about seals of the pump. So let's get started. First of all, what are the points to be considered for selecting a good pump? There are three main considerations, including understanding your pumping system requirements, second, fluid properties, and last, end-user requirement, including system flow rate and head. For the first one, we have to know the hydraulic aspects, QH, NPSH, mechanical aspects, shaft sealing, vibration and noise emission, motor selection, power motors for sealless pumps, starting characteristics. Second one, fluid properties. We have to know the liquid viscosity, temperature, specific gravity, vapor pressure, solids are present or not, and their concentration in the fluid, shear sensitive, abrasive or non-abrasive fluid. And we have to know the end user requirement, flow rate and head. Pumping system considerations. Pump system match is one of the key factors to achieving maximum overall energy efficiency in a pumping system. Pump capacity needs to be matched to the system demand at any point in time so that the pump is operating at or close to its best efficiency point. By matching the operating point to fall close the pump best efficiency point, the lowest possible losses within the pump itself can be achieved. Operational advantages to selecting a pump that operates at or close the pump best efficiency point include low radial loads on the shaft, lowest losses within the pump due to hydraulic and mechanical losses, low vibration, low internal heat generation. Negative effects of operating away from pump best efficiency point over time include pump operating at low flow conditions can result in recirculation, component damage or failure. Second, pumps operating on over discharge can result in mechanical problems and will require much greater NPSH to prevent cavitation. Selecting the right pump for the job is also important. Where an application requires the pump system to deal with a variety of demand conditions, the user needs to understand the range of operating conditions that the pump equipment must accommodate. The pump supplier can help determine the optimum pump if provided with an accurate profile of the individual sets of operating conditions that the user needs to take into account. Next question, under what situations should the centrifugal compressor be selected? Understanding when selecting a compressor basic parameters such as discharge, pressure, suction temperature, mode of operation, and gas composition and required capacity should be identified first. Steps to compressor selection and sizing. First, understanding the application. What is the compressor supposed to do? Find out the details, gas, pressure, temperature, capacities, etc. Scope of study. Who is to supply the motor, switchgear, piping, etc. Next we have size the compressor and finally select accessories. When all the above has been done, this information can be combined with what is known about the customer's need desires to generate a successful quotation. What are the elements of pump reliability? First, pump type. Second, installation, application, mechanical factors, components, hydraulic issues, operation, maintenance. What are steps would you take to achieve sustainable pump reliability? Top 10 steps you can take to achieve sustainable pump reliability are: proper design and equipment selection, proper installation and commissioning, proper flow control, proper operation, proper maintenance, stock the right parts, monitor efficiency, track life cycle history, establish a pump management program, establish a configuration management process. In this slide, we can see the reliability curve here. What is the reliability? The reliability is the zone where the pump can achieve the best efficiency point without any problem, like such as cavitation or low bearing or low seal life, or also suction recirculation, lower bearing seal life, high temperature rise in the impeller, discharge recirculation, low impeller life. The best zone is between 80% and 100% of the pump flow. This zone we can achieve the reliability of the pump, and this is the reliability curve intersection with the pump curve itself in around the best efficiency point, where we can achieve the 80% to 110 of the pump operation. What is life cycle cost LCC with respect to pumping systems? The life cycle cost LCC of any piece of equipment is the total lifetime cost to purchase, install, operate, maintain, and dispose of that equipment. Determining LCC involves following a methodology to identify and quantify all of the components of the LCC equation. What are the elements of the life cycle costs? The elements include capital cost, installation cost, operating cost, maintenance cost, decommissioning cost, which is shown in this diagram with their percentage involvement in the pump life cycle. Protocols, and specify a few of the modern protocols in use. A communication protocol is a system of rules that allows two or more entities of a communications systems to transmit information via any kind of variation of a physical quantity. The protocol defines the rules, syntax, semantics, and synchronization of communication and possible error recovery methods. Protocols may be implemented by hardware, software, or combination of both. Communicating systems use well-defined formats for exchanging various messages. Each message has an exact meaning intended to elicit a response from a range of possible responses predetermined for the particular situation. The specified behavior is typically independent of how it is to be implemented. Communication protocols have to be agreed upon by the parties involved. Communication protocols allow different network devices to communicate with each other. They are used in both analog and digital communications and can be used for important processes, ranging from transferring files between devices to accessing the Internet. To reach an agreement, a protocol may be developed into a technical standard. A programming language describes the same for computations, so there is a close analogy between protocols and programming languages. Protocols are to communication what programming languages are to computations. An alternate formulation states that protocols are to communication what algorithms are to computation. Multiple protocols often describes different aspects of a single communication. A group of protocols designed to work together is known as a protocol suite. When implemented in software, they are a protocol stack. Internet communication protocols are published by the Internet Engineering Task Force, IETF. The IEEE, Institute of Electrical and Electronics Engineers, handles wired and wireless networking, and the International Organization of Standardization, ISO, handles other types. The ITU-T handles telecommunication protocols and formats for the Public Switches Telephone Network, PSTN. As the PSTN and Internet coverage, the standards are also being driven towards convergence. Common types of communication protocols include the following: automation, such as in smart buildings, cloud technology, or self-driving vehicles; instant messaging, text-based communication in smartphone; routing protocols permit communication between routers and other network devices; Bluetooth include headsets, smartphones, and computers; file transfer, FTP file transfer protocols; Internet protocol IP allows data to be sent between devices via the Internet. The Internet cloud not operate as it currently. What are the most common centrifugal pump controls method? First, throttling. The flow caused by the constant speed pump is reduced by increasing the losses in the system by closing the valve. Use a bypassing. The flow output to the system is reduced by bypassing part of the pump discharge flow to the pump suction. The relative power consumption for the both methods. For example, throttling. When we throttling the valve for the first pump here from 10 to 7, so the power saving or the power consumption will be reduced from 100 to 89. 7 multiplied by 12.7, it is 89. It was 100 here, so it is reduced to 89. That means it is power saving. In the second case, when we use bypass, so in this direction, from 100 to 82, also we have extra power saving. So the relative power consumption is 12.4 multiplied by 6.6 equal to 82. Number 3, on-off control. On-off control is often used where stepless control is not necessary, such as keeping the pressure in a tank between preset limits. The pump is either running or stopped. The average flow is the relationship between the on time and the total time on-off, on plus off. Variable speed drive control, VFD control. With low static head systems, the optimal efficiency of the pump follows the system curve. With VSD control, the duty point of the pump follows the unchanged system curve. So the power saving or the power consumption reduced for the both cases from 100 to 0.7 multiplied by 100 equal to 70. In the second case also 0.7 by 100 equal to 70. VSD control, there is some mistake here. It should be 7 multiplied by 6.4 equal to less than 70 also. Yeah, as we can see here in this table, in the throttling, the power consumption is 89, bypassing 82, on-off control 70, VSD control 45. So this is sorry for that. Next, we have this diagram showing what we are talking about: throttling, bypassing, on-off control, VSD. They are the common configuration for pump control and centrifugal pump methods. What are the types of mechanical shaft seals? First, O-ring seal. In the O-ring seal, sealing between the rotating shaft and the rotating seal face is affected by an O-ring, which must be able to allide freely in the axial displacement as a result of changes in temperature and wear. Incorrect positioning of the stationary seat may result in rubbing and thus unnecessary wear on the O-ring and on the shaft. O-rings are made of different types of rubber material such as NBR, APDM, and FKM depending on the operating conditions. The rubber bellow seal. Second, rubber bellow seals. The rubber bellow seal can be made of different types of rubber material such as NBR, APDM, and FKM depending on the operating conditions. Two different geometric principles are used for design of rubber bellows: folding bellows and rolling bellows. We can see here also on this slide, we can see the advantages and disadvantages of O-ring seals. The advantages are suitable in hot liquid and high pressure applications. The disadvantages include deposit on the shaft such as rust may prevent O-ring shaft seal from moving axially. The second type, rubber bellow seals. The advantages and disadvantages of rubber bellow seal. The advantages: not sensitive to deposits such as rust or on the shaft. Suitable for pumping solid containing liquid. Disadvantages: not suitable in hot liquid and high pressure application. Number 3. Metal bellow seal. In the ordinary mechanical shaft seal, the spring produces the closing force required to close the seal faces. In a metal bellow seals, the spring has been replaced with a similar force. Metal bellows act both as a dynamic seal between the rotating ring and the shaft and as a spring. The bellows have a number of corrugations to give them the desired spring force. Number 4. Cartridge seal. In a cartridge mechanical shaft seal, all parts form a compact unit on a shaft sleeve, ready to be installed. A cartridge seal offers many benefits compared to conventional mechanical shaft seal. So let's look at the advantages and disadvantages of cartridge metal bellow and metal bellow seals. The advantages of metal below. First, the cartridge metal below seal. The advantages are not sensitive to deposit such as rust and lime on the shaft, suitable in hot liquid and high pressure applications. Low balancing ratio leads to low wear rate and consequently longer life. The disadvantages include fatigue failure of the mechanical shaft seal may occur when the pump is not aligned correctly. Fatigue may occur as a result of excessive temperature of pressures. Advantages of the cartridge seal: easy and fast service. The design protects the seal faces, preloaded spring, safe handling. Does a pump generate pressure? A pump produces liquid movement or flow. It does not generate pressure. It produces the flow necessary for the development of pressure, which is a function of resistance to fluid flow in the system. So, in this question, strictly speaking, all pumps create flow, not pressure, because pressure is only a measure of resistance to flow and is zero if there is no resistance. There is no resistance, the flow is zero. That means the system resistance here is zero. What about this question? If a certain centrifugal pump generates 50 meters of head pumping water with one specific gravity, how much head does it generate pumping sulfuric acid with a 1.82 specific gravity, assuming the drive is powerful enough to handle it? The motor is powerful enough to handle it. So the selection of this, the options are 27.5 meter, 91 meter, or the same 50 meter. So it will be less or more or the same. So there is actually fact rule, astonishing rule, which is a fact in the pump. The total head behaves the same way as static head. This is total head. It will behave the same as static head. Even if the fluid is denser, the total head is compared to a less dense fluid such as pure water will be the same. So the fluid in the measuring tube of the discharge or suction side of the pump will rise the same height for all fluids regardless of the density. So the answer will be 50 meters the same. Even if we change it to the denser fluid or less density fluid, it will be the same for the same pump. So the answer will be 50 meters. Next, shall we fill the centrifugal pumps before we use? Shall we fill the centrifugal pumps before we use? The rule or the fact saying that a centrifugal feed pump must not be operated unless it is fully primed. It is fully primed like this. The pump casing should be filled before starting. A suction pipe and pipe branch to be discharged. Stop valve must also be full. If the liquid enters the pump suction by gravity, priming is usually unnecessary, and the pump will remain full of liquid when shut down. To prime a pump initially or one that has become filled with air, open the small air cock here on the top of the pump casing to release the air and close it when liquid commences to flow. So almost all centrifugal pumps must be filled with liquid before they can pump efficiently. What is NPSH? NPSH is defined as total head of fluid at the center line of the impeller less the fluid's vapor pressure. The purpose of NPSH is to identify and avoid the operating conditions which lead to vaporization of the fluid as it enters the pump, a condition known as flashing, which is creating the cavitation. In a centrifugal pump, the fluid pressure is at a minimum at the eye of the impeller. If the pressure here is below the vapor pressure of the fluid, bubbles are formed which pass on through the impeller veins towards the discharge port. As the bubbles of vapor are transported into the higher pressure region, they can spontaneously collapse in a damaging process called cavitation. The repeated shock waves produced by this process can be a significant cause of wear and metal fatigue on impellers and pump cases. So the NPSH is by a formula, it is PA divided to rho G minus V1 squared divided to 2G minus HS minus HF minus PV divided to rho G. This is vapor pressure and this is atmospheric pressure and this is the velocity pressure. And here is suction head and friction head. What is mixed flow impeller? Mixed flow pumps are centrifugal pumps with a mixed flow impeller. They borrow characteristics from both axial flow and radial flow pumps and operate on a horizontal plane in relation to the flow direction of the water. As liquid flows, the impeller, the blades push the liquid out, away from the pump shaft and to the suction at an angle greater than 90 degrees. This creates enough force to generate high rates of flow. So it is designed actually to fall in about the middle between the extreme of radial and axial type impeller design. What is pump best efficiency point? This is the best efficiency point where the pump is having the best efficiency in its operation. Pump best efficiency point is the point at which the pump operates at peak efficiency. At BAP, flow enters and leaves the pump with a minimum amount of flow separation, turbulence, and other losses. Best efficiency point. What is pump duty point? It is the intersection. The duty point is at the intersection between the QH curve and the system characteristic curve. In other words, pump operating point or duty point is the intersection of pump characteristic and piping system characteristic. If the duty point was defined on the QH curve, it is possible to define other pump parameters, power efficiency using pump characteristics. The pump will always operate where the system and pump curve intersect. At that point, there is a balance between that what the system demands and what the pump can deliver. The intersection between the pump curve and the characteristic curve is called duty point here. What is shaft misalignment? Misalignment, while coupling are designed to allow some misalignment and varying degrees of flex, excessive misalignment between joined shafts is one of the most common reasons for failure. Often, a mechanic will not check the alignment before installing a new coupling and assumes that if the coupling fits, the shaft must be aligned properly. Sometimes, the mechanic does not even know that alignment is required. One of the telltale signs of coupling misalignment is the presence of dust under the part. Prevention tip: make alignment a prerequisite prior to coupling installation. Laser alignment tool make the task easy, quick and accurate. This is actually from the software of the laser alignment tool. We are doing this in the computer software between the pump shaft and the motor shaft. So wrong coupling alignment of the flexible coupling of a pump unit can cause multiple answers possible. We have 3 answers for this question: pump shaft seal leakage, pump and drive bearing damage, increase unit inefficiency. What is NPSH available? NPSH available is a function of the system and must be calculated, whereas NPSHR is a function of the pump and must be provided by the pump manufacturer. NPSHA must be greater than NPSHR for the pump system to operate without cavitating. Put another way, you must have more suction side pressure available than the pressure requires. So if a pump suffers from insufficient NPSHA, it would most likely make noise like if gravel passing through the pump, or sound which are similar to bearing damage. So this is the safe zone, safety margin for NPSHA, which is greater than NPSHR. System resistance curve. The question is, if you increase the system resistance, which an e-motor powered centrifugal pump must pump against, the revolutions per minute of the uncontrolled unit are likely, the answer will be speed up slightly, speed change is clearly measurable. This is actually the system curve, resistance curve, and this is why the RPM is increased. It is going to the same direction of system resistance increase. The RPM will be increased. So thank you for watching. This was the last slide for today. Hopefully in the next video I will bring you another subject. Write in the comments please if you have any question or any topic to talk about in the next video. Thank you.